talking earlier, and we should be live. Hello, everybody.
Live.
Yeah, for the podcast, The Full Nerd.
Hey.
We're going to talk about PC news here. We got Intel's fellow Tom Petersen.
Thank you very much for that.
We were talking about the first time you were ever on The Full Nerd. We looked it up 8 years ago. It was episode 10.
Wow.
And I actually don't know if we were live yet by then.
Oh, wow. I don't know.
Yeah.
I think it might have been fully recorded. I'm not
Yeah,
sure.
yeah. Can you remember?
If I recall correctly, I believe Will Smith was our first ever guest, and Tom was our second.
I think I was
number
2,
wow.
right?
No, you were the first guest.
Oh, first guest.
Yeah. You weren't the first industry guest, I don't think.
I don't know.
Because it might have been Ryan.
Sliced cheese?
I was very early.
Yeah,
I'm old
you're
now.
episode 10. I know Ryan from Creative was on pretty early too.
Wow.
But I don't remember exactly which number. Wow. But anyway, I see somebody in the chat here that says tap hype. So
Thank
we got
Thank
a lot
you
of hype.
person in the chat.
Tap.
I appreciate that.
Yeah. If people don't know who you are, maybe describe yourself, please, in 3 words.
In 3 words, I am a technologist.
That's one.
Yes, and I'm also a business guy. So technologist, business guy, which is classic, Silicon Valley high tech exec kind of. But I've been playing PC games since 1995.
Oh, nice.
And I was actually trying to remember the first one that really blew me away, and it was kind of a game way back in the day called Descent.
Oh, yeah.
And if you remember
me
Descent,
too.
that's a deep cut. That is a deep cut, Brad.
Yeah.
If you know about Descent,
Yeah.
it was one of those first real. I felt like I was really in a 3-dimensional world.
It
Made me a little nauseous because it wasn't super real time, but it was amazing. I loved it, and that's got me hooked.
You got a real solid 15 frames a second out of Descent back
Exactly
in the day.
on the PC with a CPU doing the render.
Now the question is, what were your controls? Like, were you mouse and keyboard?
I was AWD, yeah, mouse and keyboard.
Brad?
What about you, Brad?
Yeah, actually, I was mouse and keyboard, but I inverted the controls, and because of that and early flight stim, I still to this day, when I use a gamepad, I have to use inverted Y.
Oh,
wow, that's messed
inverted.
up, dude.
No,
that's
no
messed
way.
up.
Flight stick and throttle for me.
Really?
Yeah.
Wow.
You could use the hat to strafe. So
Nice.
you
could do yaw. And
you could circle strafe in 3 dimensions.
Nice.
Kind of.
Wow.
I love it.
Those are the days.
How does Descent run on Arc GPUs?
Descent runs great. It doesn't run Descent.
Oh, bummer. Well, we're here to talk about Arc. If you couldn't tell, we have a new GPU on the desk here. Am I allowed to touch it?
Yeah.
Yeah. All
There you
right.
go.
Well, let's
Does it
start.
smell?
It exists.
Does it smell like new
exists.
GPUs?
It's real.
Should I
was gonna-
do the smell now or wait for the
You should
actual
wait for the real
episode?
show, yeah.
I'll wait for the real
okay.
show. Yeah. This is just the pre-show.
Pre-show.
Yeah. No, we got all the friends of the show here. Ziv says Descent 2 was my first foray into flight space sims.
Wow.
Oh, yeah.
So that is really a deep cut. If you know what Descent is, then you're serious.
Well, there's a group of people that are remaking, upscaling and doing the full
Really
HD
remastering?
remake, but just as fans on Descent.
Oh,
right now.
that's cool. I did not
Yeah.
know that. You're
Like,
shitting me. They're remaking Descent?
3D. No, they're not remaking it. Fans are
It's like fan
It's like that
remakes.
They did it with Dark Forces too. So they made a 3D engine that reads Dark Forces level
my
files.
God.
And it's the same kind of thing with the Descent thing.
Oh, I love it.
know.
I
Yeah.
really want to try that out.
It probably runs like 120 frames per second. It's butter smooth.
Way more than that.
We do have a Ryan Trout in the chat. Says hi tap.
That guy.
He says inverted is the only right answer, though.
That
So
guy.
he's clearly
He's weird.
It's got to be an
He's
imposter.
weird. He knows I
Yeah.
love him, but he is weird. He does inverted. He's a redhead. What are you going to do?
And Brian says Tom Petersen in the house now. It's a party. That's true.
It is a party.
Yeah.
Totally a priority. Yeah, 100%.
Well, speaking of party, hey, I got to ask you guys, since Adam and Tom, you guys weren't here on the last episode, but I want to ask you guys this. What's your favorite pie?
Oh,
Are you a pie guy or cake
I
guy?
make
First
pie.
off.
I make
You
pie.
make pie?
Yeah, I
Okay,
make
okay.
pie. Ooh.
Serious.
I am a Thanksgiving connoisseur. I really go big on Thanksgiving.
And what's your favorite pie?
It's the deep dish pumpkin pie.
Oh,
Wow.
So I make a pie that's about 3 inches deep with a pâtisserie brie, which is sort of a very fancy French pie crust, and you cook it for a really long time, and it doesn't crack. It's beautiful. It's really beautiful. Yeah,
that sounds great.
yeah, it's really good.
Well, now I'm disappointed you didn't bring any.
I have a
to us.
picture. Maybe we can throw it in there.
That sounds good, though. You gotta send me the
What'd you
recipe.
bring? I brought an Arc GPU and also a pie. A
picture of my pie.
Yeah, picture of my
Look,
pie.
you want to get invited back more often. Bring pie.
I was going to bring morning buns. You know that.
Oh, yeah.
There's the place down on the cartoon.
Yes.
But it was so heavy traffic today, I didn't have time to run by.
The
Okay.
line is usually gnarly too.
Yeah, I used to live right over that. I used to like right there.
Oh, really? Oh,
yeah, right around the
Deep
corner.
dish pumpkin pie. Oh, man.
How about you? What's your pie?
I mean, I love pumpkin pie, but I've never had deep dish pumpkin pie. And I love deep dish pizza. Like the deeper the dish, the better. So yeah, I gotta do this. Yeah.
It's a pre-show, right?
This is the pre-show.
Right.
Anything
Stand
goes
by.
in the pre-show.
There you go.
Yeah,
Stand
we can
by.
talk about food.
No, stand by. Here you go.
Yeah.
So
Adam,
he does literally have a picture.
Ooh, are we getting a?
Oh,
You see what I'm talking about?
and a deep dish
Oh,
pecan.
wow.
Can you see that? Can we see
Wow.
that on the screen?
Wait, does the crust stand on its own?
Look at that. It's well, this is a petite brie, which is a French kind of pastry.
Yeah.
And you actually make the crust separately, and you kind of do a par bake of the pie.
You made it?
I did.
Crust.
Yeah,
Wow.
man, look at that guy. Look at that pumpkin pie, man.
That's
See what I'm talking about? Yeah.
That's serious.
Yeah.
All right. We need to end the show so we can go eat. I'm already hungry.
Yeah. Wait, Adam, what's your pie?
Pumpkin.
Pumpkin
Yeah,
pie,
but
okay,
now it's probably deep
Next
dish
time I
pumpkin.
come.
Yeah.
Next time I come. Next time I come.
Oh man, that's fun. Yeah,
Nice.
pie time. Pie.
Pie time.
I mean, we talked about it last week.
Oh,
I
you
like
talked about
I
it
like
last
a
week.
key
We'll talk
lime,
about
but on Thanksgiving it's
Oh,
pumpkin
yeah.
for
Oh,
me.
pumpkin. I make a boozy bourbon pie, which is really good. So it's basically a pecan pie with extra bourbon.
Ah.
Extra.
Oh, that's
extra
extra-
bourbon. Yeah.
So the pecan that I do is a real fine chopped nut top. So it's like phrasing also, I guess. But it's like you just get the hint of nuts and then the rest is goo.
Love it.
Which is, it's what the kids crave.
Oh yeah, that's all. You know what else the kids crave? They crave the Full Nerd podcast.
Yeah.
They
so yeah, how are the hamsters?
Hamsters are running. Everything's good.
Everything's
All the friends
good?
in the
Can you
house.
ask Ryan Strout what his pie is?
Oh yeah. Please,
just did.
Ryan.
Right. How about everybody in the chat? What's your
Yeah,
pie?
let's hear pies from the chat.
No.
Get your pies out.
Get your,
Rurudu says, "Give me chicken pot pie," which I respect.
okay.
A
I'll take
savory
it.
pie.
Oh,
Ryan, what does Kelly like? Too? I
Ryan
wanna know what
says
Kelly likes.
pecan.
What's
Yeah,
Kelly?
last week's episode, the winner is pecan.
Yeah.
Really?
Yep.
Actually, my mom used to make pumpkin pecan, and that was actually pretty good too.
Well, the thing we learned is that there are different regional berry pies too. That Brad shouted out blueberry pie, which
I love blueberry.
I love blueberry pie.
it's not something that we ever had when I was growing
actually,
up
I
in the
don't know.
mountains.
I don't know if I've ever
No.
had blueberry pie either.
Dude,
Huh.
there's like
That's
weird berries.
mind-blowing to me.
Portland has like other weird berries, right?
Yeah, you get like boysen and
huckleberry
and,
pie.
Marionberry.
Marionberries, Maryberry.
Yeah. Portland's a weird place.
All right, Piecast coming in hot.
I love Portland.
Alrighty.
Love it. All right, let's get the show going. I guess I need to bring up my notes here. All right, you ready, Willis?
Yep, ready when you are.
Here we go. In this episode of The Full Nerd, Intel talks Battlemage. Welcome everyone to The Full Nerd, PCWorld's weekly podcast about PC building. This is a very special episode today. First, I'm going to introduce the people I have with me today. I've got Will Smith here at the table. Hello, Will.
Hello. Welcome back.
Live through the internet, we've got two people. We got Brad Charkis. Hello, Brad.
Hello from the internet.
Yeah, and also on the internet is Elena Yee. Hello, Elena. Oh, and you're muted. And there
Good
it
job,
is.
me.
Hey, she's back.
Yes, good job. And also, a special guest here sitting at the table is Intel's own Tom Petersen.
Thank you very much. It's
Hello,
great to be
Tom.
back. Thank you.
Yeah,
thank you,
excited.
thank you.
And controlling the verticals and horizontals, we got Willis Lai.
Hello, everyone. Happy Tuesday.
Hello, Willis. When we are here to talk about Battlemage, we have literally a GPU sitting here on the table. We're going to get into Battlemage, all the specs of the card that was announced this morning. Not just the hardware, but we also got software surprises too.
Lots of cool
XeSS2,
stuff, yeah.
lots of cool stuff. Before we dive into it, please inform the listeners and the viewers your role at Intel, just in case they don't know, and what you do there.
That's a great question. My name is Tom Petersen. I'm a fellow at Intel, and I spend half of my time thinking about how to talk about graphics, like how do we explain what graphics are to people so that they can enjoy them as much as I do. And the other half of my time I spend, building out graphics, like doing development and engineering. So I'm in the engineering team, but I'm also kind of in the marketing team. I'm kind of straddling both words. Yeah.
Okay, so you get to inform not only the decisions behind the scenes, but also
Exactly. I'm a real
coming
engineer
out
doing
here.
real engineering work, but I'm also apparently a spokesman.
We love it when they let us talk to real engineers who do real engineering.
Yeah, and we have the lawyers sitting off to the camera here real quick. I'm just kidding.
Well, the best thing is the engineers inside of Intel think of me primarily as a marketing guy, and the marketing guys think of me primarily as an engineer. So
you can't win with either.
Yeah, it's exactly best of both.
Neither fish nor fowl.
Exactly,
Well, we got a lot to dive into here. I do have some slides that I prepped with Willis, so we'll talk about that. I've got the whole slide deck here. You did give us a pre-briefing. There's an article up on PCWorld. You can hear Brad's thoughts of the pre-briefing. So we're going to dig into it.
I'm excited.
Yeah.
What'd you think, Brad?
I believe the headline I used was the graphics card we've been begging for since the pandemic.
Oh,
so,
God bless.
let's talk about it.
God bless. God damn, I love Brad.
He's got a way with words. But before we dig into the news on here, though, there's going to be a lot of questions swirling. I need to ask any comment on the recent stepping down of Pat Gelsinger over at Intel. Anything you could talk about today, or
anything about that?
Anything?
Well,
about that.
I think that's a very great question. Of course, I'm not going to comment on the intergalactic politics of Intel. It's way above my pay grade. But I got to say that I have great respect for everything that Pat's done in the past, and everything he did while he was at Intel. So it's a transition that we're going through, and I wish him the best in the future.
Okay. Yeah. But you're here to talk about GPUs, and you got brand new GPUs that just landed today. There's two SKUs to talk about hardware wise. So please tell us about the two SKUs.
Well, we have a B580, which is right here. That's the one that is our premier SKU. It's got 5 Xe cores, or 5 render slices, which is Xe core heavy, and the B570 is a slightly reduced SKU, slightly lower clocks, a little bit less of render slices. And so the B580 is going to be perfect for 1440p gaming, high resolution, turn everything on, turn on ray tracing. And so is the B570, but it's just going to be slightly lower frame rates. So the B580 is launching at 249, and the B570 is at 219 through AIB partners.
And Willis, if you want to show slide 66, that's explaining the whole lineup. So you have a reference design. What do you call in the reference design?
I think we're calling it a limited edition, if I'm not mistaken. And when I say that, it's just similar to what we did with Alchemist, where it is truly limited edition. We're only building a smallish quantity of these because it's more like our gift to the community. It's the best card that we know how to build. It's got great thermals. It's got a beautiful ID, but it's not really cost effective for us. So we're only building a few of them not a few, but a lot of them, but not like crazy amounts.
You're not going to make them definitely for the life of this chip.
No, they are going to run out at some point. Yeah.
And you have the partners that you had before, but you have a couple new ones?
Yes, we do. Let's see. You've got the list. I would say it's
here we
go. You go. Onyx is new, and Maxon. So very excited. We're now up to 6 partners that are bringing it to the market. So Acer, ASRock, Gunir, Maxon, Onyx, and Sparkle.
Gunir, that's how you pronounce it.
Gunir.
Okay.
Gunir.
Yeah. I think I always said Gunner.
Yeah, well, I think Gunner's is an American version of Gunir. I think it's totally fine.
Oh, okay.
I don't think they mind. Gunner's pretty good.
I dig it. And then for the B570, no limited edition on that.
No
one.
limited edition. So again, it's really this card is meant to be an example of what can be done. It's got great thermals. It's very small. It's very quiet, and it runs at very high performance. So it's more of a love, like a love poem to gamers.
Okay, yeah, and it does feel it's got that same kind of muted black as the Alchemist series, and I do like the feel of the
team has done an amazing job.
There's
you can't imagine how much effort goes into like what should the texture on these things be, or what should it be a silk screen here, or what's the right orientation. By the way, I'd love some feedback in the chat. Is that the right orientation, or is that the right orientation?
Oh well,
this is the Apple. Should the logo be when you look at it, or when you're looking away?
If it's in the computer this way, I would want it this way. But for photos, I like taking photos like this.
Exactly. So our photos are all upside down, which I don't love.
Interesting. But, yeah. Okay. Well, the other new thing on this one is a flow-through design. Why adopt
It's just a great idea. The first time I saw that was NVIDIA did it on their high end. It really increases the efficiency of the thermal, and so it's a great idea. We basically have implemented a version much more cost effectively. So this entire back piece is like perfect thermals. It's got a great fin stack, and then the air can flow above it with no board blocking the air.
Is this so you don't have to do the right turn to get there?
Because if you think about this fan up here is pretty much difficult to make use of because the air is blowing the wrong direction. It kind of blows down and it goes through the thermal, it hits the board, and it spreads out, which is very difficult, and you have to run it very fast to get air in. The back guy is like, it's all downhill, baby. The air comes in, it goes swishing through. It's lovely.
Okay, I like that. And then I've been informed there's only one spot for RGB, and it's
it.
Here.
That's it. I actually think that might be white.
Oh, just white. No RGB.
I'm not 100% positive. Yeah, I think it's white.
Okay, yeah. And is that? I'm just assuming that's to keep costs down.
Yes, to keep costs. Because again, we're launching at $249, which is an unheard of price point for this kind of performance. So we got to kind of balance. I had a whole laundry list of things I want on this card that the engineering teams kind of backed us off of.
And I got to say, with this, you got a little bit of a bump on the where the fan is. So I wouldn't call this a true 2-slot card. This is just over.
I think it would fit back-to-back 2-slotters.
You think so?
Yeah, because there's actually a little bit of clearance in the 2-spot ATX spec.
Okay.
So if you look, there's this is actually right on the edge of compliance. I would say that thickness on the base plate.
Okay.
Yeah. So
interesting.
I do believe it would work. Okay. Barely.
And one just for people who are wondering, only one 8-pin PCIe power.
Right. We're 190 watts on the B580 and 100. I think it's 150 on the B570.
Okay. All right. Yeah.
Was that actually? I want to ask.
Sure.
Obviously, NVIDIA has moved solely to the 12 very high power, whatever it's called these days, connectors.
I think of it as a 12 pin ATX. What's that?
Is there a reason you guys didn't? It's just this still works just fine?
Yeah, this still works just fine. It's the installed base. It's down in the segment, and we don't need the power provided by the 12 pin. And plus this is easier to connect, so we don't want any connector breaking. And listen, I don't want to go into connector gigs. I know my friends at NVIDIA don't want to talk about that, but this is known to work.
known workable. Yeah. I like it. And so the two SKUs, the B580 is launching what was it, next Friday?
I think so. Yeah, December 13th and January 16th.
Yeah, so I guess why the staggered launch for the
the launch on the 13th, you always typically want to start with your higher end of the cards. And also, we're building this so we can control exactly the supply and availability of this. It's a little easier to manage. When partners are doing it, they need a little bit more time to get the cards, get them into the channel, and ship them worldwide. And it makes a little bit more sense to do it after they've had a chance to distribute.
So we will see partner cards for the B580 though.
Yes, of course.
Okay, but those will be launching later next year.
Well, some of them will be shipping right now into the channel, but it's really more of a staggered kind of getting availability across the world.
And some of them seem to have already listed on Amazon.
Yes, we've had a few early guys, a few early.
They're
guys.
excited.
Yeah, I don't blame them. I get excited too.
You just said something that actually makes me ask a quick question. You mentioned that typically you launch with the higher SKU first.
Yes.
This is obviously, like I just called it, the GPU you've been waiting for since the pandemic.
Yes.
This is a very affordable card. This is a 580 class. Last time around you launched with 7070 class. Intel did the same higher end first. Is there a reason that you guys, chose to dive into the second generation right here at the 250?
Yeah, Brad, that's a great question, and I get lots of this question in different forms, which is what's the reason we're here and what's the roadmap look like going forward. So to begin with, I'm not going to talk about other things that we may or may not launch because I'm all about.
I didn't ask.
No, you didn't, but I just like to get that out there, right? B580, B570, that's where we are today. I love these cards. They're going to be spectacular. And the reason we did these when we did is because they make so much sense. Like right now, there's not a lot of competition in this price range, which means that we can offer a great value proposition to gamers who like, hey, I like PC gaming, but my dad's not a millionaire. And what can I get? Well, now you can get a card that's brand new. It supports AI-based rendering, and it's great for 1440p, and it runs all the new games with great ray tracing. I mean, it's a fantastic opportunity. And so you got to pick your fights, because we're relatively new here, and this is a segment that we think we can strongly differentiate in.
It's interesting that you chose this segment because there's coming from game dev, there's a large contingent of people. Conversation you have a lot is, man, I have a really nice computer. Why can't I run this? And then you drill down into the conversation, and because of the time warp that kind of happened during the pandemic and the mining surge and all that stuff that was happening in the late 20 teens, early 2020s, it turns out they have like a 2060 and an Intel 8800 or something like that, and they're on a 6-year-old computer at this point. But in their heads, it's still new, and it seems like you position this to be a viable upgrade for folks who have, say, a 5-year-old machine that's getting a little tired.
Absolutely right, Will. And I would say that if you have an older graphics card, you can look at all the new cards about what do you upgrade. But if you're in this price segment, there's not going to be a lot that's even close, right? We're about 25% better perf per dollar than our closest competitor. We're 10% higher performance, and we have great modern features. All new modern features. So I'm pretty excited about it.
Okay, nice. We do have a couple quick questions from the chat that I want to get to.
Do it.
Friend of the show, Robert Lawrence asks, is the B570 SKU made from B580 chips that didn't quite make the 580 benchmark?
Well, the way to think about it is whenever you build chips, especially graphics cards, there are redundancies built in. And the redundancies are the idea that you're going to have some defects that happen during silicon manufacturing. So you can actually, instead of throwing those all chips out, you can reuse them and sell them as perfectly good because the defects are located in spots that you can basically just turn off in the chip. So there's a lots of science about how do you take a big chip and then skew it down to smaller chips. And some of it's business because you're trying to, say, feed more segments of the market. So you may actually de-feature big die that are good to fit into smaller segments. But in general, you try to architect your pricing and your product stack to consume the whole cow. And the cow is kind of determined by defect densities through the silicon that you're building.
Okay, all right. A couple more hardware questions, then we'll move on to the actual performance claims that you've brought today.
Sure.
Video cards with a Z, never heard of them.
Love them.
Is,
oh yeah, you've heard of them.
Is Onyx China-only brand?
I do not know. Chi is our guy who would be a better answer for that. I unfortunately can't comment on the details of the branding.
Okay. And then John Smith asks, what does it smell like, Adam? So I guess I have to do the smell test. It's not running, so it's not warmed up, but
no.
Oh, it's actually kind of a little sweet. Like a pie, maybe like a pumpkin, like a deep dish pumpkin pie.
Oh yeah,
You smell. Oh man, so were you baking a pie around this card? I guess.
I remember last time when we launched Alchemist, there was evidently a scent that came out of our packaging. Like you could smell it.
Oh,
but it was a gentle berry scent.
Oh, gentle berry.
Hints of like a smoked clove.
Yeah, like that.
I'm impressed you managed to not have fingerprints. Like the matte finish doesn't pick up fingerprints as well in the way that those usually do.
You can't imagine the amount of effort that goes into making a matte finish that doesn't show fingers.
Yeah, I like that. Okay, let's get into some performance because you've kind of alluded to it being best in class performance per dollar.
Yes.
Do we want to? Let's start with some performance claims that you have given us. Let me find the right slide that I want to get to. Let's start with 56.
Okay.
So in this one, while Willis is bringing it up, you're claiming 24% faster on average than Intel Arc A750 limited edition. So you're comparing the B580 to A750. Is that where you're thinking of as like the upgrade path, or
no? I think
not the upgrade, but
the point I'm trying to make here is gen on gen.
Gen on gen.
So
okay.
What has happened as you went from the prior generation to this next generation, and it's not really the upgrade path that I would recommend people take.
Yeah.
It's more like how quickly are we improving? And if you remember, A750 is a bigger configuration, and B580 is smaller but still faster, right? So the point I'm trying to make, if you step back and think about it, how quickly are we getting better? And it is dramatic, right? And that's kind of the message of this first slide.
My other question is here, you have listed 1440p ultra gaming, and nowhere in this slide deck do you have any 1080p results either. Yeah. Can we talk a little bit about that?
Sure.
I'm curious.
Well, I do have a slide about monitor trends, and the fact is that gamers today are almost not buying 1080p monitors. They're buying mostly 1440p, and you can tell because the Steam hardware survey is showing 5 to 7% growth per year in the installed base of 1440p. So what that means is there's been this sort of like crossover of what do gamers expect, and it's 1440p. Now, it's going to take a long time for the reviewer community to kind of like understand and move forward from that. But when it's dark out, I'm going to light a candle, and what gamers care about now is 1440p.
Could you give us any expectations on what this same chart would look like with 1080?
Very similar.
Very similar.
Very similar. Yeah. Okay. But the key, I like, this is what I tell our guys all the time. I like to make fewer points, right? And if you make fewer points, you can actually talk about them, understand them, and land them, and people will remember them. If I give you, and already I'm not like hiding the data, right? There's like 40 games, so I'm feeling data rich, but we're trying to focus the conversation to the areas that are most important.
Okay. And some of these
I'm glad you stuck to fewer points because that slide was 68 slides.
Yes. And I apologize.
Oh, no, it's great for me. I have a quick follow-up question. So obviously, one of the things I'm excited about is the enhanced memory configuration. You guys actually set this up with 12 gigabytes of memory, 192-bit bus. Like, it truly is made for 1440p.
It is.
Which we haven't really seen in this price segment since like the GTX 1060 days, which you smartly call out in your presentation.
Hey, who knew that? Take my first rodeo, Brad.
I was wondering,
let's do slide 55, Willis. Sorry.
The genesis of this card, like, were you guys responding to the 8 gigabytes ain't enough controversy? Were you targeting 1440p this whole time? Was it just like what? How did this card come to be in this form?
Well, the way I look at it is, our architects are way ahead of us, and they are already working on not the next thing, but the next thing after the next thing. So these decisions were kind of the times we were talking in Vegas. All these decisions are already done, right? And so I look at it as I count on our architecture team and our product team to kind of look forward and say, hey, 12 gig, 10 gig, this is kind of where it's at. And games are moving and technology is changing, so you need to be there. So that's the way I look at it. But then in parallel, there are just things that are going to get better. Like all the work we did on XE Core, that to me is what defines Battlemage. It's sort of like we're improving the engine by a lot every generation. And then we're trying to connect it to the correct interfaces, things like memory and things like PCI Express Gen 4. So it's a combo.
I have a couple follow-ups to that. When you say engineers are already working on the next thing and the next thing, are you referring to Celestial, Druid?
I think the way I would like to comment is our IP, that's kind of called XE3, which is the one after XE2, that's pretty much baked, right? And so the software teams have a lot of work to do on XE3. The hardware teams are off onto the next things, right? That's our cadence that we need to keep going.
So how deep is this pipeline in years? Like, were you working on XE1 in 2017?
So it's easier to talk about now.
Okay.
I would say in my estimate, the hardware design cycle kind of goes from architecture, then it goes after architecture into implementation. And then after implementation, where we're talking about RTL and debug and driver development, then after that, you've got to do hardening and then build it out, right? And there's these things take time. I would love to be at a cycle time. I think we would love to be at a cycle time where there's a new product every year or so. But, it takes a little bit longer than that typically. Sorry about my voice. I've got a cold.
No problem. No problem. My second follow-up question is the A750 and the A770 kind of had a different memory configuration than the board partners. Some of them had like 8 gig, while the limited edition had 16 gig. Will the board partners have the same memory configuration, or is it going to be different?
Yeah, that was a very unusual situation on A770 16 gig because we had actually built some of these cards as sort of like gifts to gamers, and it wasn't economical. It didn't make like economic sense to do that, but we did it because it's our first time and we're kind of partying out with gamers. But board partners could not make that make sense.
Did you have to make sacrifices to get the memory config you wanted on this board?
Well, it's always a cost benefit trade-off, and so I feel like 10, 12 gig is sort of the sweet spot for 1440p, and we're just we're going to have to make it happen. That's the way I think about it.
I mean, it gives you a competitive advantage. I assume it also helps with the AI stuff too.
It does. Memory bandwidth is the critical metric for AI. If you look at, I have a couple slides on LLM performance, and a lot of that is related both to our systolic array being a little bit better and having higher memory bandwidth access. So I think I'm going to lose my voice. I don't know.
No, that's fine. We'll take it easy on you. We'll take it easy on you. So the first chart that you showed off was comparing against the A750, and then the next chart you had. Whoop! I think I went past it. Nope, this right here. You claim 10% faster than the RTX 4060.
Yes,
which is actually a more expensive card.
It is.
Once again, this is at 1440p Ultra instead of 1080p. There is one game right here, Gears 5. Oh, no. There's a couple games. RoboCop, Dragon's Dogma. Look at this. You're already saying
Go to
that
your next one.
I know. So you're already saying you're slower than a 4060. Wow.
We do have
how
cases where we're slower than a 4060. But I do feel like this slide is a great one to think about. What are we trying to do? Right? We want to be transparent about where are we in performance and where are we in quality and what can users expect. And in general, you'll see about 10% higher than a 4060 across a broad swath of games. But if you're like running one game and you only care about that game, go ahead and like pick it out and see how do we do with that game, right?
And I'm going to ask that same question than the earlier slide. What about at 1080p?
It's going to be very similar. I would say our win is slightly higher at 1440p, but that's because we have a bigger memory interface and a little better capacity. I would say in general, it's order of magnitude similar.
Got it. Okay. The other last note that I want to point out about these charts, the configuration of the test bench features a 14900K. Why go with that over an Arrow Lake system?
I think that's what we had when we did it, right? This testing is taking some time as we go around to do it all, and we can't kind of like reset everything based on the most recent launches.
Got it. Okay. All right.
I have a couple of questions.
Sure, Brett.
All right. First, just, ARC generally, first-gen ARC, was generally best in class at video code encoding, like AV1, all of them. Is there any changes to that this time around, or is it keeping on with what's good?
It's going to keep on keeping on. So the memory, sort of the media blocks are very, very similar. It's very similar to the media block in Lunar Lake, which is very well received. And the only difference is we do not support VBC on Battlemage. So no VBC decode on Battlemage. Yeah.
Okay. And you talked about the XE cores being more efficient earlier.
Yes.
I wanted to bring this up because you guys claim it's 70% more performance per XE core,
yes,
and 50% more performance per watt.
Damn.
That's absolutely bonkers.
It is.
And I was just wondering, in broad strokes, could you kind of explain how y'all pulled that off?
I can, Brad. That's a great question. First of all, thank you. Can we pull up that slide that has the two sort of charts that show perf? It's up near the top after the XE core section, and you'll see two like lines where I call out individual microarchitectural features.
Yeah, sorry.
There you go. That's the one. Okay, so this guy is, Brad, a great one to think through. It says XE2 IP improvements frame analysis example.
Slide 19.
And I'm showing Fortnite, 1440p. So I didn't get to explain this during the briefing because it's a little bit of a complex chart. But the vertical axis is time. And so if you look all the way on the right-hand side, you'll see, what is that, like 19.3 milliseconds on the white line, which is Alchemist, and
13.
And this is the total time to render the frame.
Exactly,
right?
exactly. And if you look on the horizontal axis, that is API call. So, when you're doing a rendering a frame, it's done by DirectX, and you're going to get like lots of calls, like draw this square, draw this triangle, load this texture. And so the sequence of these commands represents the generation of these pictures, right? So as you go forward from left to right, you can see Battlemage is staying lower than Alchemist. And every time the gap increases, there's a microarchitectural feature that's being explored or exploited by this series of API calls. And so it starts off with native execute indirect. Execute indirect is a way to generate work on the GPU instead of doing it on the CPU, and it improves performance. A lot of modern game engines use that, and it matters in this very first section of this thing when we're doing a render pre-pass. And then when you get to the middle, you can see we save another chunk of time when we're doing another pass of render using execute indirect. Eventually we get to a place where we're doing, what is that called? Deferred lighting.
Deferred lighting and volumetric fog.
Yeah, and those are using, again, different features. It's native SIMD 16 and then the UAV write caching. So all of these different microarchitectural improvements are small in themselves. But when you add them up, this turns out to be about 30% faster on a per clock basis just on this one frame. So that's really the way to think about it. There's lots of these little changes all over our microarchitecture that are resulting in really significant savings.
And to be clear, this is a native render. This does not include XeSS, any
none of that.
upscaling.
This is just our
that
raster performance.
Okay.
This is their DX12 Lumen pipeline, I
Yes,
assume?
it is. Yep.
Okay.
Yep. And you can see that because there's lots of this execute indirect, right? That's really significant on Lumen.
It's interesting because this graph, like you think the length is the important thing. It turns out the height is the important thing.
Yeah.
And I didn't get that until you just went through this.
I know.
It's good to know. Those little tiny calls at the end, the ones that's a relatively small number of calls that take half a millisecond,
Yes.
are like when you're doing the profiling at the end of your game development process.
What's going on?
You're like, hey, we got to figure this one out, guys. This is the one that there's a big meeting about.
Volumetric fog, right? You know that's going to.
It turns out it's still expensive.
Yeah. And it's a lot of this. If you really look at this frame, a lot of this is compute. Right, so it's just showing you that modern games they're not doing that forward pass render. They're doing lots of different render passes, and a lot of it is compute oriented.
Yeah.
And that was one of the things that we did not optimize on our first generation of Arc. And now, obviously, we have dug in deep on compute.
I dig it. Yeah.
It's funny that Ryan's in the chat because I put out a call earlier. Hey, what should I ask Tom when he's here? And Josh Walworth from PC Per actually wanted me to ask.
Love Josh.
He's curious about whether the B series architecture helps with driver development, which clearly it does. You just said that. And is curious whether it helps with real-time compilers and can help devs. Like, is it easier for devs now?
I think so. I mean, the biggest thing I think matters for devs is, first of all, it's DirectX. You know, it's very compatible. It's very easy to just use the normal tools that you always do. But we also have native SIMD support, SIMD 16 native support, which is going to say you don't have to like recode your compute shader to match a particular topology. You can use the one that you use for everybody else, and it'll just run well on Arc. So I'm pretty excited about that.
That alone seems like a huge improvement over first gen.
We're learning. You know, you got to hit us on the head with a slam, a hammer, but we will learn eventually.
I was going to say, go ahead, Brad.
If you don't mind me hogging all the questions, I have one more before.
Go for it.
So obviously the first generation, the Arc drivers kind of came in hot. Software was an issue. You guys worked very diligently on them. Like, it's a heck of a redemption story. Like, pumped out drivers fast and furious. And largely fixed that. So I'm curious, for this generation, are you finding that the hardware changes are helping with a lot of the issues you had with the drivers to begin with? Is it like a holistic look at things?
Brad, that's a good question. Yeah, I would say to me, it's both. Obviously, our driver quality and compatibility has improved tremendously over the last 2 years. DX9 is great, DX11 is great, DX12 is great. There's no caveats at all with this card when we're launching. And I think that goes a large part to the driver team. So I want to say thank you very much. You guys have done great. But also, we've taken lessons from that and built that into Battlemage. And so Battlemage has actually got lots and lots of things that make the driver writing easier. But the truth is, once you've done the hard things, now it's more work to undo the hard things. So I would say, most of that stuff stays and kind of slowly gets removed over time. But our DX9 performance is great. DX11 is great. DX12 is great. Vulkan's great. So we know of no known issues of any kind.
And for what it's worth, it's just an outside evaluator, reviewer. They did come in hot. Like, there were plenty of bugs at launch, etc. But for the past year or so, like, you guys worked hard. The past year, like, I have an Intel system that I play around with, and I haven't had any major issues.
Oh yeah, there's one team, our DX driver team, who has done a complete re-architecture of the way DX9 and DX11 works. We call it internally Trinity, and it's sort of like this magical rebirth story because the driver was not in great shape at launch, as you know, and that team just hunkered down and worked 24/7 and said this is unacceptable, and I really have great respect for them. So good job.
Nice. We do have a question from the chat. Ben Stranad.
Nice.
For the sake of transparency, is the 4060 slower in those charts due to raw performance or VRAM limitations? I'll say you do kind of get to that in slide 63, if you can show that one specifically.
Yeah, so the performance of 4060 is not, we're not targeting any particular memory weakness there. We're just running at the 1440p ultra settings, which is the way most reviewers will test this thing. So we're not trying to exploit specific memory issues. It's sort of a overall product, delivered experience. On the memory thing.
Yeah, you do have a slide here.
In this one, I am exploiting their memory issue.
Yeah.
But
so walk us through this one.
Yeah, so this is actually a cool slide to me because we have a bigger frame buffer, and it turns out there's a reason for that. It's because games today, especially if you're running ray tracing or using higher ultra settings, they have big textures and they have big surfaces, and they will blow through 8 gig fairly regularly. So this is showing you Forza, and in the first line, it shows you the memory capacity or the memory utilization of both us and 4060. And 4060 is running at about, what is that, 6.9 gigabits, and we're 7.4 gigabits. So you can already see the game wants to use about 7 gigabytes of memory. And that, at this moment, where they're still fitting in the frame buffer, they beat us by about 10%, 86 FPS versus 77. Both are playable, both are great, but the point is they win when they fit in the frame buffer. As you start going forward, higher RT, you turn on RT, you get high settings, suddenly the game wants to use somewhere north of 9 gigabits. So 9 gigabytes. So what does that mean? Well, it's still capped at 8 gigabytes because that's how big they've got a frame buffer. So now you have to start software managing memory. You have to swap things in, you have to swap things out, and that will mess with your performance. And you can see they go from 86 to 57, whereas our drop is from 77 to 64, which switches the position. Now we're 16% faster. And it gets even worse when you go up to a high ultra. You can see the game wants somewhere around 10.6 gigabytes of memory. They've only got 8, so that's a lot more swapping, and that results in a 64% performance loss. So it is a little bit targeted here because I know how big their frame buffer is, but it's a true thing. And depending on the game that you want to run and the configuration you want to run it in, they will fall off a cliff.
I assume you're going to see that even more in the newer games. That you look at what the frame buffer that Star Wars Outlaws or something like that uses.
Yeah,
yeah.
This is an area that I've always wondered why it hasn't gotten better, right? Because we all know about managing memory, we know about caching, and you'd think that memory management for GPUs would be a little bit less of a cliff that you fall off of, and it'd be a little bit more graceful. But it's just not today. It's sort of like
Is it just a difference in memory speed on the GPU versus the PCI Express and memory bus?
Yeah, PCI and system memory is very long compared to GPU memory. So that's and GPUs, they say, are embarrassingly parallel operations. So you actually, if you don't fit, it's not like you don't fit one time. You fit for a massive selection of pixels, and all of those pixels are going to be struggling to get their data.
Interesting.
Wills, if you can bring up slide 60, you've kind of already talked about this before, but I want to get into the pricing as well. So on the left hand of the slide, you're talking about raster. On the right hand of the slide, you got ray tracing. Not only do you have the percentage differences relative to each other, but also the pricing. And it kind of works that the raster performance goes up as you go towards the B580, but the price goes down.
I know.
How does that work?
Well, how do we do that? Well, the truth is we're new, right? People are still like, hey, are you guys serious? And we are very serious. And the way to demonstrate that is we have to have a big enough value proposition that it gets the attention of users, and you say, holy cow, $249 for next gen technology and high performance ray tracing. Yeah, I'm going to give it a shot. But if I came in and said, we're right around the same as 4060, then you might be, well, I don't want to try something new. I want to go with what I know. So there has to be a benefit that we're delivering that's above where our competition is.
If you're looking at older machines as an upgrade candidate, at what point do you start being CPU bound by we're looking at the newer GPUs? Like if I put this in an 8800, where am I gonna see a big boost on my 1060?
You'll be surprised how often you are GPU limited.
Still.
So yeah, even with very old CPUs, you're still mostly GPU limited when you're playing games. I will say that we have a tool that we put out a little while ago called PresentMon 2, and in there I have metrics that you can run when you're running a game today with your current system, and there's a thing there called CPU busy and GPU busy that you can plot, and it will tell you on a per frame basis, where am I limited? So you don't have to like guess. We give you a tool where you can look at games running and are you CPU limited?
So if you play a lot of COD, you play a lot of Warcraft, you play a lot of Fortnite, whatever,
Yeah.
you can load up the game, run this, and
you'll know. Like, hey,
do your own research.
If I get a GPU, I will get a lot faster performance.
Okay.
Yeah.
I dig it. So on the other side of the chart, you're talking about ray tracing, and rightfully so, as you point out here, the AMD struggles a little bit with ray tracing compared to NVIDIA.
Yep.
NVIDIA's pushed ray tracing very heavily, but this card is still outperforming the 4060 at that same price point. Is that, I think the first argument is that the 4060 isn't great at ray tracing anyway. So is the B580 even going to be, even though it's faster, is it still going to be worth using ray tracing on a card like this?
And people are getting the thing with ray tracing that's interesting to me is that people are getting better at using it in games all the time. And it started off really kind of difficult. I remember, I think it was like Battlefield. Was it Battlefield 5 was the first ray tracing one?
4.
Battlefield.
I can't remember.
No, it was 5.
Battlefield 5.
Okay.
I remember initially looking at that title, and there was ray tracing on every pixel, and it was very expensive, right? And turning on ray tracing sent it into a ditch. But some guy said, "Hey, wait a second. What if we only ray trace water?" Right? So we'll know if it's water, and that'll be our first decision. And then after that, we'll ray trace those pixels. I'm like, well, that makes a lot more sense. So it's that kind of stuff that's emerging with ray tracing, and you're starting to see more efficient implementations. And I think you'll see more adoption in general across most games.
I think, correct me if I'm wrong, Tom, but I think that the extra memory also helps here. I think part of the reason that the RTX 4060 sometimes surprisingly underperforms in ray tracing is because it gets hit by that 8 gigabyte buffer.
It's true. It's true.
You guys having 12, does that make a difference?
It definitely does. Having a bigger frame buffer really does help with ray tracing, since ray tracings have very large data structures that you're traversing. So having a little bit more caching there can really make a big difference.
You guys also, in your slides that you presented, pointed out that a bunch of the major underlying technologies, the part of your ray tracing technology, have improved by 1.5x to 2x this generation?
Yeah,
Is that true?
per core, right? So that's a big upgrade that you can kind of imagine. We are leaning into ray tracing because it does represent sort of the next step of visual fidelity.
Yeah, that really surprised me, considering I was actually very pleasantly surprised by how well first-gen Intel Arc performed in ray tracing.
Thank you, Brad.
So I'm really
appreciate
curious
that.
to
I
see
feel
how
like I want to hug you. Can I get
A virtual
No,
hug.
the review hasn't
somehow.
come out yet. This is all before it gets serious, Tom.
Yeah, you're going to start testing it, right?
Yeah.
Nice.
Well, I mean, there is still plenty of questions about ray tracing, and people still seem to be. I feel like they're, compared to where they were 2 years ago, people are still kind of like tepid on it. Like they're more excited, but they're still like, how many games are actually out there?
Yeah.
Like, do you feel like people are buying new GPUs based off of actual ray tracing performance?
I think it's more of a wait and see attitude on ray tracing right now, similar to things like neural graphics. Like if you said years ago we're going to use AI to generate pixels, most people are like, I think I'd rather just have what the game wants. But now when we tell you can improve performance by like 3x by doing AI rendered pixels and it looks better, that'll get people there. Now with ray tracing, what's cool is it plays together with this idea of generation, because the more expensive a frame is to generate, the better scaling it up through AI is. So our real strategy is let's render smaller with ray tracing, really high quality. And then AI will learn what does ray tracing look like when you scale it up. And it does really look really, really good. And it has great performance with ray tracing and XeSS2.
Okay, so let's talk about XeSS2.
Yeah.
There's a lot going on here. It's basically, I don't want to, you've got upscaling, you've got frame gen, and then you've got latency management.
Yes.
Which is kind of the trifecta that it seems like everybody's landed on at this point.
It's necessary.
Yeah. Just because it seems like the latency management and the frame gen kind of go hand in hand. But let's start with upscaling, because this is a new version of XeSS. The first
It's
question,
got a 2 on it.
has it? Yeah.
Well, it does. XeS2 is the collector. So it's all these technologies, and we've sub-branded them each, so people can have switches if they want. XeSS SR, XeSS FG, and XeLL.
So from an implementation perspective, there's a bunch of interesting things happening here. So you have driver level support for some of this stuff as well,
Yep.
which means it just applies to everything theoretically. But from an implementation standpoint, are there additional plugins now for FrameGen and low latency, and you're still using the old XeSS plugin so your old XeSS1 upscaling games will work with the XeSS2 hardware and the new cards?
So the way to think about it is there's a different SDK for XeSS SR versus XeSS FG versus XeSS LL.
And they're all, I assume the implementation for them is your Unity or Unreal plugin, but it's the half day of engineer time.
Yeah, and if you think about it, these SDKs, I call them, are very similar to other vendors.
Okay.
So if you've done the work for, say, DLSS3, or you've done the work for Reflex, or you've done the work for DLSS2, you'll find integration with our stuff to be very, very similar. And over time, you'll see plugins for most of the major game engines.
It's the typical thing where you expose the vectors and the frame buffer and all that stuff.
Exactly.
Okay.
So a big question I had, and a lot of people in the chat have as well, is XeSS2, all these new technologies that we're going to talk about in a second. Is this also going to be available on Alchemist? Is it also going to be available on things like Lunar Lake, Meteor Lake?
Yeah.
Going
Great
back.
question. So we like to enable things on place where we can, right? And so XeSS2 does rely on XMX for acceleration, which is our matrix extensions. It's our systolic array. So XeSS2 will work on Alchemist and it will work on Lunar Lake, but it won't work on Meteor Lake because Meteor Lake does not have the required hardware.
Okay, so all XeSS platforms except for Meteor Lake.
Yes.
Okay. Well, let's dig into it. Yeah. So for the FrameGen, or I'm sorry, the super resolution specifically, walk through the changes for this one.
Okay. Well, the algorithm is very similar. We've continued training and we've added more data. So obviously the network itself is getting better and smarter. We've also added support for DX11 and for Vulkan. So in this generation of our SDK, now if you're doing a DX11 or a Vulkan game, you can add XeSS and it all works just fantastic, right? So XeSS as a technology has not dramatically rechanged. The models are getting better and the support base is getting bigger.
And is for you all, XeSS runs on the matrix math part of the GPU, so it's not impacting performance at all?
Well, it does because there's a constrained power budget.
Okay.
So it's kind of like you take a little bit here. What it does is it generates pixels a lot more power efficiently than render.
Okay.
So think of it as, you want to render small and then use XeSS to go big because it's more power efficient than the alternative.
Is the XeSS2 stuff still cross-platform as well?
Great question. So we have not changed our cross-platform policy on XeSS. Right now, we don't have cross-vendor support for XeSS2.
Okay.
We've had lots of requests for it. It does help with software adoption, which we want. So we are looking at it, but it's a much harder thing to make happen.
I assume with Lunar Lake shipping, your installed base for
Huge.
GPUs that are compatible is going to be really nice.
Yes.
Without needing that cross-platform
That's
support
true.
this go around.
Although it's sort of like being a good corporate, a good citizen of gaming. We'd like to find ways to make these things easier and common for ISVs. So this is a plug for anybody at Microsoft who is thinking about standardizing post effects. I would love that, and we would definitely support you. It's like this super res thing they've done where they're standardizing the API interfaces for super resolution.
Yeah.
There's a whole world of post effects that are crying out for standardization, and we would love that.
I would love it for latency draw calls, whatever the thing that powers XeLL.
Yes.
Now developer has they have to manually implement Reflex.
Yeah.
Radeon anti-lag and yours, right?
It's kind of crazy, Brad. You're absolutely right. And that's where DirectX really went crazy, right? It went through the roof because it's saying there's only one way to do graphics, and that's called DirectX. Well, now there's one way to do graphics, one way to do raster, but there's lots of different ways to do these post effects, and that's not good for the ecosystem. Yeah. So, we'd love that to change.
I mean, it is literally when you're looking at, especially small devs, you're looking at two people in your company who can do this implementation, and everybody's coming at you with, "Hey, this takes a half day. This takes a half day. This takes a half day," and it's never really a half day.
No,
It's always like a day or two, and then there's some UI stuff.
Yeah.
So building a system level API for this would be really nice.
I think it would be. have in the past partnered with NVIDIA on this in the space on something called Streamline, which I still think is a great idea, but we weren't able to come together on the fundamental goal. And the fundamental goal is we want to do one integration, and that integration has to work for all vendors. It can't be you do one integration and then you send a dev tech team back to that place to get your UI implemented. That doesn't make any sense. So it has to be one integration, and then we're all good.
Okay. So let's move over to frame generation, because this is new, and it works alongside of or can work alongside of super resolution. Walk us through the frame generation implementation.
Well, anybody who knows me knows I've been talking about interpolation for at least 10 years. I love it, and the NVIDIA guys love it. I think it's great. But the idea is it's very expensive to render. Right, so if you can find a way to use rendered frames to generate content that's just as good as a rendered frame.
You mean fake frames?
Fake frames. I like to call them fancy frames.
Oh, okay.
Yeah, so if you can generate a frame that gives you a better experience, it's a good idea. In this case, we're using a current frame that just got rendered along with an older frame, and then we're calculating what's the most likely frame that goes in the middle. And by doing that, we're increasing the frame rate, which improves immersion and animation. That's why you like higher frame rates. It's because the step of motion is smaller, and that makes your brain relax a little bit. It looks a little bit more realistic. The technique we're using is dual AI networks. One AI network is called optical flow reprojection.
I don't know if I give you slide 30, Willis, but...
Optical flow reprojection is a very fancy network, and what it does is it calculates the most likely vector field for pixel motion. So you're looking at, hey, there's a blue pixel here in the old frame and the blue pixel's here in the new frame. So it's likely moving along this vector. And what you would do if you're going to use that to estimate an interstitial frame, you would just say, it's likely halfway between in the middle. So if everything's moving smoothly in this optical field, then you could generate a frame and it would be everything perfect. Now, the problem is that optical flow projection is not perfect. And there's things that don't work, and it's estimating, right?
Well, if you're accelerating, then the halfway will be a third
or the lighting
whatever.
changes, or fog rolls in, or because all the pixels don't appear in the destination. So it's an estimate. And then similarly, we have a game engine that has motion vectors, depth, and color buffers, and it can give us that information, and we can generate a different estimate of a frame. And in this case, we're saying the game engine is telling us what objects are moving in three-dimensional space, and we know where it was, so we know where it's going, so we can actually estimate where it was in the middle. Right, so it's sort of, think of it as a game engine data-based estimate of where were things halfway along the way. So now we've got at least two pictures. One is optical flow-based, another one is motion vector-based. We have another AI that's called Blend, and the Blend is responsible for learning, given all the stuff that's going on around, what's the best way to look at all these pixels and make an estimate for the middle. And so there's more than two. There's some secret sauce in here, some really smart engineerings, but you get the idea. We're going to have algorithms that generate multiple estimates of what the middle frame would be, and then we're going to train an AI network to blend those together and generate the best possible middle pixel.
And these are generic algorithms, not specific to games.
Well, they're specific to gaming, but they're not specific to a specific game. Yeah, there's not like 10 models or 100 models or 1,000 models. There's one model. Well, two models, but one.
One bucket model.
Yeah.
Yeah.
And this happens all before the UI, so that can still get rendered.
Yeah, I had a couple of people ask me about, well, I don't like the fact that the UI is not being estimated, but that UI problem is actually super hard because, it does things like the one picture was showing 799. The next picture shows 800 on the UI because you're looking at a gauge. What's the interpolated image? Is it a blur between 800 and 79? No, it's not. You want one of the numbers.
You want the actual number.
Yeah, because if you put a blur in there, it actually looks terrible, right?
Well, and also there's no performance impact to rendering the UI at whatever frame rate you're getting with interpolation.
Yeah.
Is frame generation vendor specific? Meaning, does this only work on Intel GPUs?
Today, that's the case. Yeah.
Oh, okay.
Vendor specific.
So, going off of that, it sounds like I know this because I asked you yesterday. It sounds like the reason you guys are able to offer backwards compatibility is because you're doing all this on the existing XMX extensions.
It's not, Brad. It's not all on the XMX extensions, but parts of the algorithm that are efficient to accelerate are on the XMX extensions.
Okay, sorry, I misspoke. And that's why you're able to offer backwards compatibility where NVIDIA isn't with the DLSS3, right?
Well, that's part of it. There's a whole bunch of software reasons that we haven't yet enabled multiple third parties. You would have to find a way to do that in a vendor neutral way, which means that it has to be some kind of HSL, kind of like a code for a compute shader. And that's not the way we implement it today. We use custom kernels that are done on our side that accelerate the specific algorithms. And those kernels don't exist in a third-party sort of vendor-neutral form. They're just written on our own language.
Is this something that you think Microsoft could ever standardize in some way, since we were just talking about them?
Well, I think what needs to happen is you'd like to standardize the APIs for the games and then have an architecture that would allow a vendor to plug in a execution engine underneath that API. Right.
So you're standardizing the inputs that you take to feed into the AI algorithms.
Yeah, exactly.
Rather than,
but it's more than just standardizing the inputs. We need a standard way to do a game harness. Like how does a game understand options? How does a game understand UI? How does a game provide callbacks and provide textures and provide color buffers? All that needs some standardization.
Because you need a way to hook those UI threads in, so you automatically populate, this game supports FSR, XeSS, or
absolutely, okay. Yeah, and you'd like the UI to change based on the platform.
Does the frame generation work on Lunar Lake?
Yeah.
So you can run frame gen on the 2 slices or whatever in a Lunar Lake?
I'm not sure the slice number, but yes.
Yeah. Okay.
Yes.
Fascinating.
Yes.
We have a question in the chat from POV. They ask, how different is this than other frame generation technologies on the market?
Excellent question, POV. So I don't have the detailed implementation knowledge of any other's implementation other than our own. So I can't really comment on what anybody else is doing. I will say that we don't have a requirement for optical flow hardware, and that allows us to be a little bit more broad on our enablement.
Okay.
Okay.
And a follow-up to this, Denever1G1, friend of the show, gives a $10 super chat. Thank you so much. Said, I don't like frame gen because it increases the latency, making most games feel worse at all FPS ranges unless I'm playing a game where the input latency doesn't matter. DLSS great generally reduces latency. So, do you have anything that'll help battle latency?
Wow, it's almost like there's a straight man out there, right? What a segue. We did also address some of that latency objection, right? Because when you're doing interpolation, you're necessarily adding latency because you're holding on to 2 frames longer than they otherwise would have been displayed because you're calculating the middle frame. Now, it is true that while we're calculating the middle frame, we're showing the first frame. So it's not like you're waiting for 2 frames. You're waiting for basically 1 additional frame to calculate the middle frame before you show the next frame. Right?
And it's like it's a reduced calculation time for that middle frame.
It is. Yeah. But it does cause the second frame to wait, right? Because you're basically trying to center that generated frame. So we invented this technology called Xe low latency, or XeLL. And what it does is it integrates into a game and then adjusts the point at which they sample input and when they run the render so that we can drain the pre-render queue and drain the render buffer and go directly to execution without having like a whole bunch of stuff queued up.
So this slide 35, Willis.
Yeah, this is showing you effectively that click gets picked up by the blue frame in the original on the top, and then it sits in the render buffer for a little bit, eventually renders on the GPU, and then shows up on the screen towards the end of that picture. And with XeLL, we're able to shift over that purple frame. So instead of catching it with the blue, we're going to catch it with the purple, and that purple then doesn't have to wait on the render queue because we've drained it. We're not going to allow work to queue up in the render queue, and so it goes directly to the GPU, executes, and then shows on the screen much quicker. And this does require a game integration. Now, the cool part is we know exactly what's going on inside of the GPU. So we can know how long we want to sleep the CPU so that it can finish its work just in time so that the render queue doesn't really ever run empty. It's just never going to be buffered up.
Okay, and you have a real world example of what this looks like in terms of timing on slide 38, please,
Yes.
Willis.
So native render, you're seeing about 57 milliseconds of delay. When you turn on XeLL with just the native render, it comes down quite significantly, and we drop 45% of the latency just by doing this trick of sleeping the render thread or sleeping the CPU part, and so that we can drain the render queue and catch clicks later.
Okay.
So it seems like, and then if you turn on super resolution, then you see another decrease because
we're showing two things here. When you turn on XeSS2, the frame rate jumps up, right? It goes up to like 90 something, and that act alone reduces the latency because as frame rates go up, latency comes down because frames are shorter. The time that it's queuing in the render queue is reduced just because they spend, each frame is quicker. But when you turn on XeLL as well as XeSR, you can see latency comes all the way down to 19 milliseconds, which is crazy. So we're now applying higher frame rates and using this XeLL technology.
It's like I mean, I'm not good at math, but it's almost double the frame rate. But
1/3 or 1/4 the latency.
I mean, it's what, 11 milliseconds for a 90 frame per second render or something like that?
Yeah.
I have to open the calculator, just full disclosure.
Oh, good. Oh, wow. Okay, yeah.
I can't divide by 90.
Smart guy over here.
Good job.
But it's interesting that you're seeing that reduction in frame rate from 40. I mean, it's because you're reducing memory bandwidth, so your fill rate's going up because you're rendering lower resolution,
sure.
right?
Yeah.
Okay.
The other thing to note here is that when you turn on XeSS2, latency would have otherwise gone up. Right, XeSS
because of the frame gen,
just the frame gen. Yeah, but with XeLL, it actually comes all the way back down to near optimal. Even though we're adding an extra frame of delay, the frame rate goes up so high, and using XeLL brings it down back to a very low number.
So the TLDR here is if you want the best latency, you turn on super resolution and low latency, but leave frame gen off.
Yes, that would be the lowest resolution, but you would be giving up a lot of performance, which is emergent, right?
And are you feeling like the frame gen is primarily a thing that enables ray tracing at this kind of price SKU?
It certainly enables it to be much more broadly useful.
Okay.
But I would say that frame gen in general, I always turn it on because it is always a better experience, almost.
Okay.
Yeah.
Okay. Are you a gamepad or a mouse and keyboard?
I'm a mouse and keyboard guy.
Okay.
Yeah.
Right
now it's not so important to me because I'm hooked on the space age expansion for Factorio right now.
Okay.
So if you've ever played Factorio, it's thousands of hours.
You just want more of those CPU cores for that.
Yeah. It's all sprites, right? They don't. Yeah. I think they use something called GLFW. I think is their framework that they're using. It's 100% sprite based. It's locked at 60 FPS, but I love it.
Yeah.
I have a question just while we're talking about this sort of stuff. I've noticed when playing around with DLSS3 on the 4060 that the closer you get to the memory capacity, filling it up, if you turn on frame gen, it kind of gets stuffed. Is that something that actually happens? Does frame gen affect memory use? Is that another case where 12 gigabyte could be beneficial?
Well, frame gen does affect memory use because you're holding on to more buffers, right? But the buffers shouldn't be giant, compared to some of the big buffers. So I'm thinking it might be other ancillary effects, but it's possible, Brad.
Yeah.
I don't know the details on that. Yeah.
I don't remember my testing details from a year ago either. I just shoot it out there.
Anything you're saying that's bad about them, I tend to believe you.
Okay. So I was going to say the other thing that's changed is that you have driver level support for some of this stuff too.
We do have driver level support for XE. We call it driver low latency mode.
Okay.
And what that's doing is very similar to XeLL, except no game integration. It's all in the driver. And we're stalling on a return to present. So game engines you normally call present to say, hey, I'm all done with my draw calls. Go ahead and put this on the screen. We're going to hold on to that call and not return it with the intention of stalling the game engine, similar to what we do with XeLL. And that actually drains the render queue and lowers latency, but it doesn't require game integration.
So how does this interact with low latency monitor technology? Like are you supporting FreeSync and?
Yeah, all that works. G-Sync. Well, we don't support G-Sync. We support adaptive sync.
Okay.
And adaptive sync is the industry standard way of doing variable refresh monitors.
All right. Yeah, that was a question. Another super chat from Alva Jonathan gave us 50,000 IDR So it sounds like 50,000.
Good job.
Indonesian rupees.
Indonesian. Oh, well, thank you. That's awesome. And kind of ask the same kind of question. Does XeSS FrameGen have frame pacing logic so it can be used with VSync?
It does have frame pacing logic, but that's more about pacing the generated frame, right? So think of it as when you generate a frame, it gets rendered really quickly, but you don't want to show it right then. You want to show it in the middle of the other two frames.
Yeah.
And similarly, you don't want the frames that you've generated to go on the screen right away. You're going to hold on to them. So all of the back end of when does a frame present moves from being as fast as possible, which is what you typically do. You finish rendering, you put it on the screen as fast as you can. Now you need to start thinking about what's the right pace. When should these things be shown? And sooner is not better. So it's absolutely, it's a very similar technology. I've been looking at frame pacing for years as well. I think there's more to be done in this area, obviously, but we're not there yet.
It seems like a place where there's a lot of work happening right now.
There is. Yeah, there is.
And is low latency, is this something that it can be across all Intel products, or is this once again locked to XMX? Things that have XMX?
I don't know the answer to that. The answer is it could be. I don't know if it is.
Okay.
Because I think it actually may be connected into XeSS2. And XeSS2 is restricted. So I think there's like possibilities there, but I'm not sure.
Okay. Yeah. Because I would love to hear that.
Follow-up question on that. Do you think there's a possibility that we'll see some games choose to implement XeLL but not frame generation?
I think there's a possibility there. Again, we're very early in the rollout and the engagement with ISVs, and they get to decide obviously what they want to do in their games. Yeah. But I would hope that if you're going to spend the time to do the integration, you would just get everything. But again, I don't know. I don't know yet. I don't know. I think I'm saying I don't know.
Okay, yeah. So we covered all that kind of stuff. You have I do want to talk a little bit about the AI Playground because it feels like that just launched, but you have a 2.0 version.
We do.
Now?
We're obviously working on our things, making it better. This is now integrated and it supports XMX. So our AI Playground is XMX accelerated. We're using all the latest models. So depending on how up on LLMs you are, how big on generative AI, you can now download everything that's all the current stuff, and it gives you an easy way to experience Gen AI in the safety of your home.
So I don't have to download Anaconda from a command line and
no
do
Python.
a bunch of weird Python stuff.
No Python. No Python. I love that stuff, but most people don't.
Have you been getting a lot of requests from users to have good generative AI support?
I think it's
you
more
have a whole
like
slide on it.
Yeah.
It just literally just
people
says generative AI.
want Gen AI. It's more like, hey, Gen AI is a thing. And a lot of people are starting to realize the world around us is changing. And it can be scary. It can be like, we don't know really what's happening. So what we're trying to do here is to say, here is a real example of Gen AI. You can literally type into this UI and you will get exactly what you asked for, and there's no human involved. It's actually crazy.
And it's running locally, too.
It's running locally,
as opposed to going up to some server someplace that somebody else owns.
I actually did a video, and I did a little gag, and I'm like, hey, let's pretend I'm a marketing guy, and I need to launch a new GPU, and it's going to be competitive with NVIDIA. I'm all typing this into my Gen AI plot. I need marketing collateral showing a Battlemage with a neon sign saying Battlemage and standing above a bunch of dragons wearing leather jackets, green dragons wearing leather jackets, and dancing. So I did that. I got like literally a great picture that we might just use.
I got to say, I am impressed still that the link that you can download it from Intel's website, but you can also just clone the GitHub repo still. So like, something, keeping it real.
We are very real.
Yeah.
Continuing with the software stuff, you do have some updates to the Intel graphics software.
Yes.
Walk through some of these things.
This is effectively our control panel. We have three main capabilities. One is display settings, so all the funky things you might want to do that's vendor specific on display, things like scaling models and retro scaling and all that kind of stuff, now available in display settings. There's a 3D settings, which does all the typical things for 3D that are game independent, things like our new low latency mode, endurance mode, FPS limiter. And then we have a performance panel, which is our overclocking and monitoring tool. So we have full support for OC at launch. It's really great. I show a few examples of how clocking works and how this enables it, right? So in this slide,
I think it's slide 50, Willis.
We have a VF curve built into every part, which is how it like picks the clock to run at. And as you're moving up and down this VF curve, it's kind of selecting your performance level automatically. And now with these overclocking tools, you can shift that up and get higher performance basically for free. Now, the reason we don't ship it like that is because we like to have margin and all that kind of stuff that makes parts not crash. But end users actually don't care that much. We're a very conservative company. So if you push it up a little bit, everything is probably going to be just fine. Yeah. So that's what this whole panel is about. And we actually have a whole bunch of statistics that are coming from PresentMon, which is also a tool from Intel. And that is now available in our expanded control panel.
And I will say, Wills is bringing this up, the fine print says altering clock frequency or voltage may void any warranty, product warranties, and reduce stability, security, performance. Blah, blah, blah.
Yeah, I wish I'd seen that before. I wish I'd seen that.
May void warranties.
I probably would have taken that out if it were me. I probably would not have said that.
as in, it won't void your warranty.
Well, your warranty is a deal between you and your card provider.
Okay.
And in our warranty, it doesn't say anything about overclocking affecting your warranty, and so it in fact does not. So I would have
for the Intel cards.
Yeah, for the Intel cards.
For the Intel cards.
And for the AICs, I think what we're trying to do is be extra careful. But again, I do not know of anybody who actually does in fact affect the warranty.
Would there be a way for them to know?
It'd be very, very difficult and not worth it.
Yeah. Can we talk about power for a sec?
Yeah, please.
I'm curious what this is the one that's like a mobile. It's the same GPU core on mobile and desktop.
Yes.
And I wonder what the power draw situation is like at different kind of workloads. I have a bunch of streamer friends who put Arc One Alchemist cards in their machines to use as like the video encode engine because you guys were doing AV1, all sorts of other stuff early. And I wonder, like, what's your workload with the video stuff going? What's your workload with the in games? What's the power draw at different situations?
I mean, there's a lot of people asking about just idle power draw too.
Yeah.
Well, I think the idle power is very, very good. So starting from idle power, there's something called ASPM 2.0, which is a feature that Intel effectively did years ago, and it's enabled in your motherboard BIOS. By default, a lot of motherboards are turning it on, and it should be turned on. It's just advanced power management. And our graphics card relies upon that capability to get to its lowest idle powers when we're running with high refresh rate monitors and large refresh rate monitors. So as long as you do that, you're going to get leading edge, very low idle powers. If you don't do ASPM 2.0, you're going to get slightly higher power levels in some high resolution, high refresh rate scenarios. But in general, you'll still get really good low power with idle. But it is an area where, I think we have more to do, but it's pretty good, and it's great if you turn on ASPM. Now, the second question is, what about media playback? We have very efficient hardware decode for all codecs. We have, not all, but like all common
the ones people use. Yeah.
And then we also have hardware encoding codecs for the ones people use, except for VVC. So as VVC is rolling out over the next couple of years, not on Battlemage, but on Lunar Lake.
Okay.
So yeah, pretty good.
And then games
are great.
We know what the wattage is.
It's what did we say? 190 watts on the total package. And you'll see this card, oddly, does not run at that power. So this card actually typically runs much lower than that, and it's almost always running at its peak frequency. And Brad, you'll see this when you start testing. It's designed with a tremendous amount of power headroom.
Cool. Oh, wow. Okay. We did have a super chat come in once again from Alva Jonathan. Gave us another 50,000 IDR.
Damn.
Thank you. Wow.
How much is that?
Just rolling in. I'm going to say it's 50,000 US dollars.
That sounds good. Everybody's getting a bonus.
Yeah, there we go. Thank you. Can we set a fixed voltage and frequency, or do we have to use an offset?
Can you set a VIX? Well, so we do support a locked voltage in our SDK. So if you look at the SDK that's out there, there is a fixed voltage option. In the UI, there's no option for locking a fixed voltage. So you'd have to do something custom yourself to lock a fixed voltage. And you can also, in the curve editor, you can like do a curve that's restricted so that it's not locked, but it's moving around in a small range.
Okay. In a follow-up, friend of the show, Ziv, asks, I wonder if there's any good undervolting support, if, for example, if they want to cap it at 100 watts.
Yeah, you can. I believe we support, and maybe Nick, you can help me. I believe we support a negative frequency offset which is actually the same thing as shifting down your curve and running on a lower voltage at the same frequency, which is the same thing as undervolting.
Got it.
Undervolting. Can you? I know the answer to this. I'm pretty sure, but does the XMX engine allow you to turn on Copilot Plus features in Windows?
So I don't think that I don't know. Okay. Caught me a fluster there.
I got
You got him with one.
But I do not know of a technical reason why that would not be the case.
Okay. Okay.
But I think in general, Copilot Plus is more targeted today at MPUs.
Yeah.
Which is appropriate given the mobile form factor that they're going after. But next year, I would like to see that change as you see more and more Copilot Plus features that are more relevant for desktop users.
Okay. Yeah, the background blurring, if nothing else.
Yeah.
Yeah. I'm just going to keep going with here we go. Shfrac 2K.
Love it.
Like that. Can you unlock power limits?
Well, you can raise power limits. So I believe on each card can be different. So depending on the AIC in their firmware, the bias that they have on that card, they'll have a limit that they picked based on the hardware that they built. On our card, I think it's, Nick can correct me if I'm wrong, I think it's 25% higher on power on our card. I think, is that right? For how much more power can you add? I think it's a 25%, but that's not like a limit that we're picking. It's just how big a power supply did we build?
Got it. Okay.
Okay.
I think that's everything from the presentation straight up itself.
Love it.
I do have some random questions.
Please do.
Brad, Elena, do you have some questions
Those
too?
are all excellent questions,
Yeah.
by the way.
Anything?
I want Elena to go first. Elena, do you got anything?
I'm still trying to figure out how to word it, so you should go first.
Okay. I have another question from Video Cards with a Z. I don't know if they spell it wrong on purpose, but why does the B580, B570 doesn't have PCIe 5.0?
Well, because it does have PCIe Gen 4. So It's just any kind of product question. It's a great question. And this has come up because there have been some leaks about PCIe Gen 5 on this card. So I just thought I'd address that. From time to time, we do build technology that is built into these devices that does not get productized. And that is the case here. This is a Gen 4 product, but we do have other technology inside that might have enabled PCIe Gen 5. But today it is PCIe Gen 4, and that's just part of the product. So it's not like, why is it not Gen 5? It's because, the ROI for Gen 5 is moderate, and especially in this class of device. So Gen 4 is actually perfectly sufficient, and it's only the leaks that have kind of caused this to be a confusing.
Is this one of those situations where you're looking at like where you can spend your budget, and bigger RAM bus, wider RAM bus, more RAM is more impactful than bigger number?
Yeah, it's very similar. Like, do you need Gen 5 for this kind of card? And the truth is you don't, obviously, because the numbers that we're putting out are fantastic, and those are all Gen 4 numbers. Okay. So I would say the reason it's come up at all is because Gen 5 is kind of hot right now, and people are getting ready to launch Gen 5 cards, but it just doesn't turn out to be relevant for us right now.
Got it. A follow-up off of that, Sergio asked, is rebar mandatory for Battlemage as well?
Well, mandatory is the wrong word. It's strongly recommended because you're going to get better performance, and it's actually strongly recommended for everybody because everybody gets better performance. But it's not required. But all the numbers that we put out use rebar on.
Okay, I like it. We've got another super chat from Alva Jonathan. This time it's 100,000 IDR. We're just swimming in money. Thank you. Santa came. Yeah, Santa came early. Yeah. Asked, hi Tom, a big fan. Can you elaborate on how? Oh, okay. There we go. Thank you for the translation.
Thank you very much.
Can you elaborate how 19 gigabit per second, 192-bit bus on the B580 would serve enough bandwidth for a 1440p workload? I assume B580 doesn't have any kind of big caches like its competitors.
Let's see. We do have caches, but how does that memory interface support that demand. It's more like, well, there is compression on that interface. So think of it as you're writing and reading across that interface, you're not doing the raw bits of the frame buffer, you're doing compression. So it's sort of the proof is in the pudding, right? We know what the performance is at 1440p. We know it's on that interface. So it does deliver the required bandwidth. And it's a combination of, knowledge about lossless compression and bandwidth management and caching that makes it all come together in a wonderful, frothy, delicious gaming experience.
Yeah, I think people lose fact of the lossless compression and the fact that compression has got so much better over the years.
Yeah.
Because everyone's used to, hey, you need a 500 and whatever bit, 384 bit thing to be able to game it 1440p 4K.
Yeah.
It's just not true anymore.
It's simply not true. I did, Brad, a little bit of a video on compression when we did our media stuff, and the depth and the knowledge of evolution of compression technology is really shocking. But it's a simple idea. Like, if you can find a way to not transfer 100 zeros in a row, don't, and just have a special token that says there's 100 zeros here. And then when you see that special token, you can expand it on the other side of the interface. So it's not like you're getting any compression artifacts. There's
no loss.
There is no loss. It's lossless. All it does is it saves the bandwidth for actual needed data transfers. It's a really fascinating science. I recommend anybody who wants to go find, there's a video I did on how does media work on our devices, and it goes deep into compression.
Okay. So Mr. Vipitus asks, why go with interpolation instead of extrapolation for frame generation?
Excellent question. So the question is, why interpolation, not extrapolation?
Extrapolation.
And the difference, for you, if you're not like into this as much as I am, extrapolation says, take my current frame and then project the next frame. And maybe take my current frame and the one before it and project my next frame. Interpolation says, take my last frame and my current frame and project the one in the middle and then show them in order, right? So adds latency. Extrapolation is preferred. But the problem is, it's a much harder problem because you don't know the picture that you're trying to get to. So you know where you are. When you're doing interpolation, you know where you are, you know where you're trying to go, so you can kind of figure out what the middle is. With extrapolation, you don't know where you're going. So it's just like, what's the most likely next picture? And that's based on a lot of different assumptions about motion vectors and physics and, lighting and reflections, and it's super hard.
And what's the penalty if you get it wrong?
If you get it wrong, the question is, what do you do? The game is still going to render the correct one, the following frame. So it adds this sort of jitter into the image if you're wrong.
Okay.
Yeah. Now the interesting part is, what if I didn't do that? So there is a really good idea here. That is, what if I just never show you a rendered image, and I only show you my interpretation of images, right? And so what that does is it turns the render into a hint into your AI that is actually generating the experience that you see.
Well, in this case, so then you're still generating frames from a game versus training a video generator on Minecraft videos.
Yeah, so it's like a couple years ago I did a interview and I said, long term, like 20 years from now, we're not going to have game engines. We're going to have game assets that are fed into an AI that generates a game. Generates game images, right? Because why wouldn't you? And I've actually saw a paper from NVIDIA where they're showing actually asset generation from that kind of stuff. So think of it as a middle ground, kind of like hybrid rendering. You can easily imagine where you don't show the rendered frames. You use those rendered frames as an input into an AI whose job it is to give you an optimal experience. And that means it can be 100%, 120 hertz locked. Right, and you're going to get a buttery smooth experience because this is what the AI does. And what it's doing is it's taking updated game information to update that series of frames that it's showing you. It could be really cool.
And in that context, the AI frame generation is a fixed time for every frame?
Probably, yeah.
So you're taking something that right now takes a variable length of time per frame and turning it into just a...
Yeah, it's like a movie.
Yeah,
you'd be watching a movie with perfect physics.
Yeah.
Right?
Yeah. It's like... Oops! All fake frames.
Yeah,
yeah.
But it's not. It's fake.
People are gonna love this.
Yeah.
You should get ready with this marketing message now, Tom. They're gonna go.
It's 100% fake frames.
Yeah.
Yeah. No, but I think there's a slide in here where I talk about graphics is changing, right? It's going from game engine defines a frame and it's lossless. I would like you to generate this frame. I told you what to do, generate the frame. And we're already past that. We're already into the mode where 1 in 8 pixels is generated with 1 in 8 pixels is rendered with XeSS2.
Yeah.
7 out of 8 are generated.
Huh.
Well, part of that is just because when you expand the resolution on the same amount on both axes, you're multiplying each pixel by 4.
Yes,
right?
and then we're doubling it with
and then
generation.
you're doubling it again.
Yeah.
Matt in the chat says he can already hear all the outrage ponies.
Well, we're not
writing.
doing any of this.
Yeah,
We're not doing
yeah,
any of this.
okay.
This is not happening.
And Kyle Wilde says it's like that version of AI Minecraft, but it's not, because the idea that you're pitching is you're taking the game engine, you're rendering this based on game state,
Yes.
whereas that AI version of Minecraft just knows what Minecraft looks like.
Yes.
And it gives you something that looks like Minecraft.
Mine is not a plan. It's a more of like, hey, this could someday be. So don't say that we're working.
Blue
on it.
sky.
Yeah.
So
Yeah.
Druid,
Yeah.
going to be all fake frames confirmed. No, I'm just kidding.
Thank you, brother. Thank you. Thank you.
I want to get back to you, Elena.
Hey,
Well,
sorry.
Elena, have you
I'm
had a
going to
chance?
cut you off real quick.
Oh.
I just want to say I think that calling it fake frames kind of sucks. Like, I get it at first, considering the initial issues that DLSS had, but like Tom just said, like 1 out of 8 pixels in the game that you're playing, if you're turning on XeSS2 with super resolution, is already AI generated. Like, this is the future. If we want cards to keep getting faster without busting reticle limits and stuff like that, radical new technologies kinds of a thing, this is the way to go. So I think people just need to get in their head that, hey, AI matters just as much as the basic GPU.
Yeah.
Well, and with the thing that's happening with the latency, like if we continue seeing the latency drops, if we get another half of the latency time on a frame, we're going to be looking at no difference in latency on the generated frames versus the live frames.
Very true. And I feel like latency also has AI has not arrived in the latency game yet.
Yeah.
Right. So I don't know how much I should say. But
nobody's watching.
Yeah,
It's fine forward looking.
You can imagine AI getting involved in here, right? So Brad, what would AI do in a latency reduction world? Like, what would you imagine that would look like? What's the fundamental problem with latency? You're waiting for somebody to do something, and then you're trying to get the result of the doing something on the screen, right?
Yeah, I'm moving my cursor on top of somebody's head, but the computer thinks their head is in a different place than where I'm seeing.
Yeah. So what if you could predict where a person was moving?
I mean, it sounds like I would have kind of an advantage in multiplayer games. But
Well, you could really think about AI as the fundamental problem we're trying to do is reduce the time from an action to a pixel, right?
Yeah.
So you could do that a couple different ways. You can make the pixel faster, like make the pixel respond faster to the click, or you could estimate the click earlier.
So you're assuming you're pre-firing the pre-fire is what I'm hearing.
Well, or maybe it's not on the click, but maybe it's on motion.
Yeah.
Right. If somebody's moving your mouse like this, you know where they're going.
Mm-hmm. Yeah.
Right.
Yeah.
The competitive people are going to love this.
Yeah.
It's going to be really, really
Yeah.
popular.
I'm just saying, there's a whole world out here. The world is changing, guys. The world is.
Every time you come on here, you make me think of things in very different ways.
There you go, brother. Trying to help, Brad. Trying to help.
I like it. Data says, if AI can help trick me into thinking I'm good at games, then I'm maybe
AI can definitely do that.
But I mean, at the end of the day, if we're talking about a world where AI is generating a lot of the frames, there's no reason to buy a high-end expensive card. You just buy something that has the right matrix math
Maybe
units and call it a day.
I don't know. I think there's always going to be a continuum of experiences that we can deliver depending on hardware variation. And so today we think of that as render.
Yeah.
Right. You get more render, you get a better AI, experience. Someday that's not going to be true. It's going to be I have to have some render, and then what I really want is bigger AI to get better experiences.
Interesting.
Elena, I want to get back to you with your question. Have you thought of some phrasing?
I have thought of some phrasing, but I also just want to comment real quick on this topic, which I love because it almost seems like we're in store for a bunch of metaphysical conversations about, what it means to play games, how they are created for us. And like Brad said, my brain is just racing down all these different paths about that. Like the conversations we're going to see online, if this comes to fruition, are going to be amazing.
Yeah.
And you can take that word amazing any way you want, whether in the actual literal definition or,
You mean the heat?
as in good.
The heat?
So my question is going to actually take us back down to like the very nuts and bolts, very not as metaphysical kind of questioning, which
Please.
is so more as a more practical person. If I were somebody who thought, based on today's announcement, this is great, this sounds great, I want one of these cards, but sometimes it's really dicey trying to get one like right out the gate. If I miss that first window, either because everyone piles on board or I'm late to buying it, when the partner cards come out, a lot of times they're not at the announced price point. A lot of times they'll add like different kinds of things to the card to increase the price. For people who really love that price point, can you talk yet about what they can expect from those partner cards, like the price points they'll be looking at?
That's an excellent question. I know it's a big concern that a lot of people have is like you guys said $249. I don't see a card at $249. So it is in the control of the partners about what do they build and how do they go to market. But we have pretty firm guidance about $249 needs to be hit by all partner cards. But that doesn't mean they don't deliver variation that's faster. They can overclock their cards and they can have bigger power supplies and better fans. And I expect those will be more expensive over time. In terms of availability, sadly, it's the same story. I can say that we'll have some limited volume of this particular card available on launch day at retail, but it's up to our partners to go through their distribution channels, worldwide distribution, and I have no control over when those will literally be available. So I wish Chi was here, who's our guy that really works closely with the partners. He could give you a little bit more color, but I'm just optimistic because partners respond to cues they get from the market. And if the market demands the parts, they will rapidly respond because that's what they do really, really well at.
Okay. I dig it.
Excellent question. I wish I had a better answer for you.
Yeah, but we're running up on time, so I got a handful of questions. I do want to come back to the power limit question. So I'm being told off camera here that AIB models may vary, but the negative frequency offset possible is negative 300 to plus 1,000
nice
megahertz.
So we can undervolt.
You can undervolt.
And by the way, if you don't believe negative frequency is undervolting, then we should have a chat.
Okay. So I'm just going to rapid fire some of these. We had a super chat a while ago from Dan C. Gave us $4.99. Thank you so much. Said, are the workstation SKUs going to be available for consumer purchase? Alchemist had business class GPUs, but only from system integrators.
Well, again, I don't make comments on things that haven't been released, so I have no comment on workstation SKUs.
Okay. All right. Old Man Withers asked, how is Linux support?
Linux is great. We've done most of the upstreaming already, so Battlemage will be fully enabled on Linux distribution, so coming soon.
Okay. Zoidreth has the same question that they asked last time. How is Battlemage looking for VR?
Well, right now we don't have VR support. And the truth is that requires a collection of work both on our side and on the VR headset side. And it's just not at the critical spot for this product point right now. So in the spirit of like full disclosure and focusing on most important things first, we decided to not work on that yet.
And what does that look like? It just won't even detect?
I don't know.
You don't know? Okay.
I don't know. But saying no VR support is the easiest way to deal with it.
Okay, all right. Here's a good one that Mark Hockman had, PCWorld's own Mark Hockman. Drivers and bugs have been an issue in previous releases. What's been done to nail this down for this launch?
Well, it's an excellent question, and the problem is a big problem. It's a very complex problem, but we have invested gigantic resources into addressing it. Gigantic.
Wow.
Is that a technical term?
Yeah, it's like enormous and gigantic at the
He's
same
an engineer.
time. Yeah.
He would know.
So think of it as we've done more than 50 driver releases since we launched Alchemist. That's 50. And those driver releases have all gone through massive QA cycles. We've increased our game coverage by 2.5x. So hundreds and hundreds of games are run every week looking for validation regressions. So it's only through testing and architecture and hard work that we can get our driver quality where it needs to be. But I feel very comfortable that we are over that hump. And this is really going to be either earth shattering for me as we get out and there's like hundreds of millions, hundreds of thousands of people that buy this card, and I'm going to be delighted when they say this is rock solid, or it's just going to shatter me. So I don't expect the second one.
It's nice that you laid it all bare there. For
Yeah.
us.
Yeah.
You also scaled back hundreds of millions users. Aim high,
millions.
Tom. Aim high.
Hundreds of millions.
Yeah, hundreds of millions cards. Yeah, there we go. That's the
I don't know.
expectation.
I'm an optimist.
Any last round of questions from you, Brad, or Elena?
No, man, we need to get this man some honey and
Yeah.
Thank you. Thank you.
I'm not going to make him talk anymore. I could talk all day. But
Okay. Yeah. I do need to ask this one as
Can I get one?
Yes, please.
What about using these as secondary cards for the video encode or GPU accelerated
Perfect.
stuff?
Works
It'll still
great.
Work. Okay.
Yeah, works great.
Okay, I dig it. Then last question I hear from Nice Bunny. I'm gonna move it around a little bit. Is there any chance that a B570 would be seen at CES? And if it did, if it was seen at CES, what would it look like?
Wow. I actually don't know, but I would expect so, but I don't know.
Oh,
wow!
Expecting a B570 at
oh no,
CES.
B570. I thought you said
no.
570.
No, B770.
Okay, I take that back. I have no comment about B770.
Yeah, I was like, wow, okay.
I take that whole thing back.
Everybody, the team of lawyers
just
jumped up. People are waving the red flag.
Pulling the cables.
Okay, I apologize. I thought he said 570.
Okay, I like but the B570, so that launches in January 16th.
I would expect
12th,
to see those around there. Probably.
Expect to see
it's certainly in private rooms, if not.
Okay.
Out on the floor.
Okay. All right.
Sorry.
And will we see you at CES?
I don't know. I mean, I'm going to have to rest. We'll see. We'll see.
Rest up. Well, thank you.
Rest up.
Thank you for hanging out with us, coming down. Always good to see you and have you here in person.
It's fantastic.
I want to thank Will Smith. Check back next week for your talk on the Full Nerd, PC Talk on the Full Nerd. To listen to us on the go, subscribe to us on Apple Podcasts, Spotify, YouTube Music, Pocket Cast, anywhere you could point your RSS feed to. And please rate and review us on any of those services. Every time you do, Tom comes on and announces an unreleased product. I want to thank you, Tom, for coming on the show. Always a pleasure.
You did great again.
No, it's fun. You make it easy. Thank you.
I
want to thank Will Smith for hanging out, asking the good technical questions.
Good to meet you, Tom. Yeah, thanks for having me as
a
always.
Real pleasure.
Thank you, Brad, for joining us digitally.
Yeah, of course. You've got me intrigued, Tom. I can't wait to actually.
You're going to get a hug next time I see you. You were fantastic.
Not when you're coughing.
Elena, thank you for zooming in as well.
Thanks, Elena.
I would like to just put my name on the list for trying this deep dish pumpkin pie.
Oh yeah.
Yes.
Yeah. Okay.
We're gonna talk about recipes after the show.
And last question I need to ask. So it's available on December 13th. When will reviews be available?
What's review date? The 12th. The 12th and 13th.
Okay, awesome. And thanks everybody for joining us. Thank you, Willa Slide, for controlling the verticals and horizontals.
Very nice.
Hopefully, we didn't give you too many slides to juggle around, but get us out of here. We got to eat some pumpkin pie.
Thank you, Adam. I'm the only slide I'm missing is that deep dish pumpkin pie slide. But
next time.
We'll bring it up next time.
I'll send it to you.
Yeah. Thank you, everyone, for tuning in, and we will see you next time. Bye.